Here also we can apply L'Hopital's rule, that is limit as extends to 0 of 1 minus cos 2x by x. When you put x equals 0, you can observe that it is cos 0 by 0. That is 1 minus cos 0 means 1 minus 1 by 0, which is 0 by 0 form. So when it is taking 0 by 0 form, we can apply the L'Hopital's rule, that is limit as extends to 0 of 1 minus cos 2x by x is equal to limit as extends to 0 of derivative of the numerator, that is 0 minus derivative of cos 2x is minus 2 sine 2x. Derivative of cos 2x is minus 2 sine 2x and derivative of x is 1. That is I have limit as extends to 0 of 2 sine 2x by 1. When you put x equals 0, you will get 2 into 0, that is sine 0 is 0. I will get the answer as 0, which is in option A. If x tends to infinity of 1 plus 2 by x to the power of x is equal to limit as x tends to infinity of 1 plus 2 by x to the power of x. This limit we need to evaluate now. For evaluating this limit, I will mention a formula which is very important, that is limit as x tends to infinity of 1 plus 1 by x to the power of x is equal to e. So you can note this formula. We can apply this formula here. Limit as x tends to infinity of 1 plus 1 by x to the power of x is equal to e. Now I will bring the given limit to this standard form, that is limit as x tends to infinity of 1 plus, let me write this 2 by x as 1 divided by x by 2, and we have power x here. I will divide this power by 2 and also I will multiply the power by 2, so that 2 will be cancelled and we have x in the power, and 1 plus 1 by x by 2, that is 1 plus 1 by x by 2 is same as 1 plus 2 by x. So we have manipulated here, so that in place of x in this formula I have x by 2. So the term inside the square bracket is nothing but e, that is limit as x tends to infinity of 1 plus 1 by x by 2 whole to the power of x by 2 is e, and we have a square here, so that answer is e square, which is in option C. Evaluate limit as x tends to 1 of 2x minus 3 into root of x minus 1 by 2x square plus x minus 3 is equal to. So we have to evaluate this limit. There are two ways to solve this question. One is we can apply L'Hopital's rule because it takes 0 by 0 form. We can check. And second one is by factorizing the denominator and also by multiplying the conjugate of root x minus 1. Let us try both the methods. Whichever is convenient to you, you can adopt that method according to the given problem. Now I will check whether it takes 0 by 0 form. When you give x equals 1, I will get 2 minus 3 into 1 minus 1 here divided by 2 plus 1 minus 3, which is equal to 0. 1 minus 1 is 0 into minus 1 0, and 2 plus 1 3 minus 3 is 0. So we have 0 by 0 form. So we can apply L'Hopital's rule, that is limit as x tends to 1 of, I have 2x minus 3 as first function. Derivative of root x minus 1 is 1 by 2 root x, plus second function is root x minus 1, and derivative of 2x minus 3 is 2, and derivative of 3 is 0, we need not mention. And in the denominator, when you differentiate 2x square, you will get 4x plus derivative of x is 1. When you put x equals 1, that is when you apply the limit, you will get 2 minus 3 into 1 by 2 root 1 plus 0 here, because 1 minus 1, root of 1 minus 1 is 0. And in the denominator, I have 4 plus 1, that is 4 into 1 plus 1. So we have minus 1 by 2 by 5, which is minus 1 by 10. Minus 1 by 10 is the required answer. That is option A is the correct choice. So this is by applying L'Hopital's rule. We are applying product rule in the numerator because I have two functions here. That is, one is 2x minus 3 and another is root x minus 1. And in the denominator, it's a polynomial function. We can directly differentiate it. Now let us see the alternate method also, which will be little bit lengthier compared to this method what I have explained now. Let me consider the same limit here. Limit as x tends to 1 of 2x minus 3 into root x minus 1 divided by 2x square plus x minus 3. Now let me factorize this 2x square plus x minus 3, which is equal to 2x square minus 2x plus 3x minus 3. These are the factors. So let me take 2x common so that I will get x minus 1 plus 3 into x minus 1. When you take x minus 1 common, it is 2x plus 3. So denominator is nothing but limit as x tends to 1 of x minus 1 into 2x plus 3. And in the numerator, I have 2x minus 3 into root x minus 1. Next, what I will do is I will multiply by the conjugate of root x minus 1, that is root x plus 1 divided by root x plus 1. We know that root x into root x is x, and minus into minus I have x square x minus 1. So I have limit as x tends to 1 of 2x minus 3 into x minus 1, that is a minus b into a plus b is a square minus b square, and I have x minus 1 into 2x plus 3 into root x plus 1, root x plus 1 here. Root x, I have square root for only x here, that is root x plus 1. X minus 1 is eliminated. Now you can apply the limit, so that I have 2 minus 3 divided by 2 plus 3 into square root of 1 plus 1, that is 2 here. So in the numerator I have minus 1, and in the denominator I have 5 into 2, which is minus 1 by 10. So this is the alternate method for this L'Hopital's rule. So answer is minus 1 by 10. If limit as x tends to 0 of kx into cosecant x is equal to limit as x tends to 0 of x into cosecant kx, then k is equal to, now let me use the given expression, that is limit as x tends to 0 of kx into cosecant x, which is equal to limit as x tends to 0 of x into cosecant kx. We are supposed to find the value of x which satisfies this given equation. Let me write this given expression as limit as x tends to 0 of kx divided by cosecant x can be taken as 1 by sin x. So I have kx by sin x. So kx by cosecant x is same as kx by sin x. Similarly, I will write this limit as x tends to 0 of x into cosecant kx. I will write it as x by sin kx. So that is x cosecant x is nothing but x by sin kx. We know that limit as x tends to 0 of x by sin x is 1. So we can all note all these formulas. Limit as x tends to 0 of x by sin x is 1. Limit as x tends to 0 of tan x by x or x by tan x is also equal to 1. So now I have sin kx. So I have to multiply this by kx and let me divide by k. Here also I have kx by sin x. So I will write it as limit as x tends to 0 of this k is constant and we can keep it outside, that is by the property of limits, k into limit as x tends to 0 of x by sin x. We know that limit as x tends to 0 of k into f of x is equal to k into limit as x tends to 0 of f of x. I have applied that property here in the left hand side, that is k into limit as x tends to 0 of x by sin x, which is equal to limit as x tends to 0 of kx by sin kx into 1 by k. It is 1 by k here. It's 1 by k. So now this value is 1 here. This value of this limit is 1, and similarly the value in the right hand side is also 1. So this implies I have k into 1 is equal to 1 into 1 by k, which implies k square is equal to 1, or k is equal to plus or minus 1, which is in option C. K is equal to plus or minus 1. Limit as x tends to 0 of log cos x by x is equal to, as usual we have 4 options. When you put x is equal to 0, you get log of cos 0 divided by x, that is 0. So log cos 0 is log 1 by 0, log 1 is 0, so we have 0 by 0 form. Here in this problem also we can apply L'Hopital's rule, that is limit as x tends to 0 of log cos x is 1 by cos x into derivative of cos x is minus sin x divided by derivative of x is 1. That means I have limit as x tends to 0 of minus sin x by cos x, minus sin x by cos x, that is limit as x tends to 0 of tan x, that is minus tan x here. When you put x equals 0 here, that is when you apply the limit, this will be minus tan 0, which is equal to 0. So option A is the correct choice. Evaluate limit as x tends to 0 of sin 2x by x. When you apply the limit, you will get sin 0 by 0, which is 0 by 0 form. So you can apply L'Hopital's rule, that is given expression, that is given limit is equal to limit as x tends to 0 of derivative of sin 2x is 2 cos 2x divided by derivative of x is 1. That is when you apply the limit now, you will get 2 cos 0, which is equal to 2 into 1, which is 2. Another way is By manipulation also we can find the answer for this question. Limit as x tends to 0 of, I have sin 2x in the numerator. I will multiply this by 2, that is denominator is multiplied by 2 and numerator is also multiplied by 2. Now the limit of the term inside this bracket is 1. So it is 1 into 2 which is equal to 2. So option D is the correct choice. If f of 9 is equal to 9 and f dash of 9 is equal to 4, then limit as x tends to 9 of root of f of x minus 3 by root x minus 3 is the value of the limit which we are supposed to find. Now if you apply the limit directly, you will get root of f of 9 minus 3 divided by root of 9 minus 3. Root of f of 9 is root 9 minus 3 by 3 minus 3 which is equal to 0 by 0. Now we can apply L'Hopital's rule to evaluate this given limit, as it is taking 0 by 0 form. So limit as x tends to 9 of, when you differentiate root of f of x, you will get 1 by 2 root of f of x into derivative of f of x. Derivative of f of x divided by root x. Derivative of root x is 1 by 2 root x. You know that when you apply chain rule, d by dx of root of something is 1 by 2 root of something into d by dx of something. According to that, root of f of x, when you differentiate root of f of x, it is 1 by 2 root of f of x into f dash of x. Now let us apply the limit. So you will get 2 into root of f of 9 into f dash of 9 divided by 1 by 2 root of 9. So let us substitute the values. F dash of 9 is 4 by 2 into square root of 9, that is root of f of 9 is root 9 which is 3, and divided by 1 by 2 into 3 here. So 2 into 3 and 2 into 3 is eliminated, and I have the answer as 4 here. So option B is the correct choice. To evaluate this given limit, that is limit as x tends to 0 of modulus of x by x, I will find left hand limit first, that is limit as x tends to 0 minus of f of x, that is limit as x tends to 0 minus of modulus of x by x. When you are approaching 0 from left hand side, the value of x is minus x, that is I have limit as x tends to 0 of x by minus x which is equal to minus 1. Similarly, I will find right hand limit, which is limit as x tends to 0 plus of f of x, which is nothing but limit as x tends to 0 plus of modulus of x by x, which is nothing but limit as x tends to 0 of x by x which is equal to 1. Clearly left hand limit is not equal to right hand limit, therefore limit does not exist. Limit does not exist. So option D is the right choice. Evaluate limit as h tends to 0 of root of x plus h minus root x by h. Let us multiply and divide by the conjugate of the numerator. So given expression becomes limit as h tends to 0 of root of x plus h minus root x into root of x plus h minus root x, that is here I have to write plus, that is the conjugate of the numerator. I have root of x plus h minus root x in the numerator. I am multiplying and dividing by root of x plus h plus root of x, and in the denominator I have h here. So now limit as h tends to 0 of numerator is in the form of a minus b into a plus b, which is a square minus b square. That is, I have x plus h minus x by h into root of x plus h plus root x. Now x is eliminated and I have limit as h tends to 0 of h by h into root of x plus h plus root x. Now h is eliminated. Now as h approaches to 0, you will get 1 by 1 by root x plus root x. That is, when you put h is equal to 0, you will get 1 by root of x plus 0 plus root x, which is nothing but 1 by 2 root x. So answer is option A here. Evaluate limit as x tends to 0 of 2 to the power of x minus 1 by 1 plus x to the power of 1 by 2 minus 1. As x approaches to 0, let us see what is the value of the limit. It is 2 to the power of 0 minus 1 divided by 1 plus 0 to the power of minus 1. That is 1 minus 1 by 1 minus 1, which is equal to 0 by 0. So clearly we can apply L'Hopital's rule again here, and we know that d by dx of a to the power of x is a to the power of x into log a. This is a standard result. Derivative of a to the power of x is a to the power of x log a, and dy dx of x to the power of n is n x to the power of n minus 1. So now this given limit, that is limit as x tends to 0. This is the limit, and we have in the numerator 2 to the power of x minus 1. When you differentiate 2 to the power of x, you will get 2 to the power of x into log 2 divided by derivative of 1 plus x to the power of 1 by 2 is 1 by 2 into 1 plus x to the power of minus 1 minus 0. Now when you put x is equal to 0, you will get 2 to the power of 0 log 2 divided by 1 by 2 into 1 plus 0 to the power of minus 1 is minus 1 by 2. You know that 1 to the power of minus n is equal to 1 to the power of n is equal to 1 for any value of n. So now it is 2 to the power of 0 is 1 here, and I have log 2 divided by 1 by 2 into 1 here. So answer is 2 log 2. This 2 log 2 can be written as log 2 square, which is equal to log 4. We know that k log m is equal to log m to the power of k. When you apply this rule here for 2 log 2, this becomes log 2 square, which is equal to log 4. So option B is the correct choice.